All right, section 6.4, sum and difference identities. So now that we have talked about some of the basic identities, we have done some simplifying, we've done even some proving along the way. Now what we're going to do is we're going to introduce you to some other ones, kind of see how they fit in, and then we can apply these to later on as we start to simplify and prove, okay? So we are going to be looking at the sum and difference identities, which means you're trying to see if we can break something down to make it look a little bit nicer, or can we take something that we were not able to solve and make it actually happen. So I'm going to take you to here where you're trying to determine what is the exact value of the sine of 45 degrees. Well, we know that the sine of 45 degrees, that's on our unit circle, and that takes 45 degrees, so that's the square root of 2 over 2. That's the exact value. Well, what about the cosine of 15 degrees? We don't have 15 degrees on our unit circle. We have 30 degrees, we have 45 degrees, we got 60 and 90, we got all those multiples. So we try to look at, well, what's another way that we can come up with 15? Perhaps using the 30, the 45, the 60, and the 90. And I'm going to show you here that we could take the cosine of 15 degrees and say rewrite it as 45 degrees minus 30 degrees, because 45 minus 30, that gives us 15, right? So how are we going to use that? And that is what we get into the sum and difference identities. So we have the cosine of u plus v equals cosine u times cosine v minus the sine of u times the sine of v. You cannot distribute. Okay, notice that that's not what this is getting. You're not distributing that cosine. There's a specific formula that we have to do here, and I'm not going to get into the proof behind it, but what I want you to realize here is that you can't just distribute it. It just doesn't work that way. You're taking the cosine of this sum or of this difference, so you have to be very careful about that. Notice that something's happening. Why is this put up on me? There we go. Notice this is the cosine of the sum between the two, and notice that's using subtraction between them. Cosine of the difference, notice that's using the addition. And then just when you look at the first part, you're taking the cosine of the first angle times the cosine of the second angle. Now, when you see this in textbooks, you're going to see them combine these two formulas into one. So they're going to do the cosine of u plus or minus v. So there's your plus or minus. Then notice how that transforms over here into the formula. And then it goes into cosine u, cosine v minus plus. And that's just to match up the fact that the top here and the top, so if you're adding, you're going to be subtracting. If you're subtracting, then you're going to be adding. So just want to show you that value part. So now let's go ahead and see if we can evaluate what the cosine of 15 degrees is. So I'm going to rewrite this like we did earlier. We could do the cosine of 45 degrees minus 30 degrees. Now, you could also do 60 minus 45. That would be possible as well. You could work with the larger angles too. You could take, I'm trying to think here, you could take 150 minus 135. You can do all of those angles as long as the sum or the difference adds up to being 15 degrees. So now notice here that 45 degrees, that is my u, and the 30 degrees is my v. So I just need to make sure that I'm plugging everything into the right spot here. So we can take the cosine of 45 degrees times the cosine of 30 degrees. And because I'm subtracting here, that means that we need to add. And then we'll take the sine of 45 degrees times the sine of 30 degrees. Now we can evaluate these because we know the cosine of 45 degrees is the square root of 2 over 2. We know that the cosine of 30 degrees is the square root of 3 over 2. Sine of 45 is the square root of 2 over 2. And the sine of 30 degrees is 1/2. So now I multiply. Square root of 2 times square root of 3 is the square root of 6. 2 times 2 is 4. Square root of 2 times 1 is the square root of 2 all over 4. And then since I have common denominators, we end up with square root of 6 plus the square root of 2 all over 4. And that is the exact value of the cosine of 15 degrees. Now, sine has slightly different formulas, but kind of the same too. You just have to be careful. That's why you've got your notes. The sine of u plus v, you're taking the sine of the first times the cosine of the second plus the cosine of the first times the sine of the second. So you're kind of mixing them up this time. Notice that your signs stay the same with that. And so when you see how it might be looked at in a textbook, you'll see the plus or minus here. Well, you're going to see plus or minus here. Because if you're going to add, you're going to add. If you're going to subtract, you're going to subtract. So how would we take the sine of 7 pi over 12? Now, working with angles, those are usually, people like doing those a little bit more, just because it's a little bit, it's easier to see. Radians, people struggle with a little bit. But I want you to think about here, and I'm going to go down here to the bottom. Think about our radians that we work with, okay? So you've got pi over 3, you get pi over 4, you get pi over, I suppose I missed pi over 6, and then you got pi over 2, okay? With all of these, when you're adding or subtracting, when you're working with fractions, you need to have common denominators. So what I'm going to do here is I'm just going to rewrite these so they all have a common denominator, which its common denominator would then be 12. So pi over 3, that would simplify to 4 pi over 12. Pi over 4 would simplify to 3 pi over 12. Pi over 6 would simplify to 2 pi over 12. And then pi over 2 would simplify to 6 pi over 12. And obviously you've got more that you can be working with once you get into the other quadrants. But what I'm going to look to see here is, can I use these values right here to help me get to 7 pi over 12? And what would work is if I were to take the sine of 4 pi over 12 plus 3 pi over 12. So ultimately here we're taking the sine of pi over 3 plus the sine of pi over 4. Now, could I switch these around? Yes, you could do pi over 4 plus pi over 3. The only ones you have to be really careful about is when you're doing subtraction, because the order does matter. So now going up to my formula here, I'm going to take the sine of the first. So I'm going to take the sine of pi over 3. I'm going to multiply it by the cosine of the second radian here, which is pi over 4. I'm adding, so I'm going to add here. Then I'm going to take the cosine of the first times the sine of the second. And now, since we're trying to find the exact value, I can go ahead and plug in these values. So when we take the sine of pi over 3, that's the square root of 3 over 2, times the cosine of pi over 4, which is the square root of 2 over 2. Cosine of pi over 3 is 1/2. And cosine of pi over 4 is the square root of 2 over 2. So I multiply, and I get the square root of 6 plus the square root of 2 all over, well, I suppose maybe I should, before I jump here, this should be over 4, and this is over 4. So the exact value for the sine of 7 pi over 12, square root of 6, plus the square root of 2 over 4. Now, notice that that is very similar to what we did with when we did the cosine of 15 degrees, okay? And even though, like, you would be adding here, let's see, what are we doing? I guess I forget here. We'd be taking 60 plus 45. Realize that that's going to put us into different parts of our unit circle. And sometimes you're going to have the same values, just like how sine and cosine are sometimes the same. Alright, so that's sine and cosine. Now when you get to tangent, you have to be a little careful, okay? So there's two formulas, obviously, for tangent. But these formulas here don't work for every angle measure and every radian value. That being the reason why is because there are some values for tangent where tangent is undefined. Okay, we don't have a value that exists for that. That being said, that happens when you're taking the tangent of pi over 2. So a little side note right here says that if u or v is equal to pi over 2 or 90 degrees, or you could also say 3 pi over 2 is not going to work, or 270 degrees, then you have to go back to using the basic or the quotient identities of taking sine over cosine. And you'd have to work at it that way. Since you can take the sine of pi over 2, you can take the cosine of pi over 2. And that would be a way to get around that. So let's just take a look here at the tangent of 15 degrees and what I want to use for that. I'm going to go with something different than, instead of using what we did 45, let's see, at the beginning we did 45 minus 30. So I'm going to pick something else that's 15, just to kind of give us a little bit of a different range. How about if I take the tangent and I'm going to go 150 degrees minus 135 degrees. Okay, so I'm just going to work over in that second quadrant. I'm still going to get the tangent of 15 degrees here. Now I'm working with 150 and 135. Excuse me. So I don't have to worry about having anything undefined, okay? So now when I take a look at my formula here, I'm going to take the tangent of 150 degrees. I'm dealing with a minus, so minus, I'm going to subtract here on top, so tangent of 135 degrees. Divide this by, and it's going to be 1. And since I am subtracting, I then have to add in the denominator here the tangent of 150 degrees times the tangent of 135. Now, this is going to test your simplifying, and you're working with fractions. Tangent of 150 degrees is, and I should have mine simplified on here. One second. Alright, so tangent of 150 degrees is negative square roots of 3 over 3 minus the tangent of 135, which is negative 1. Divide this by 1 plus the tangent of 150, so negative square roots of 3 over 3. And the tangent of 135, which is negative 1. Alright, so now you get to the simplifying part. I'm going to kind of work off to the right here so I don't take up too much space. Common denominator between these two. First of all, if you want to do your double sign change, you by all means can do that. 1 would be the same thing as 3 over 3, right? So then when I'm adding these together, I'm going to get a negative square root of 3 plus 3 all over 3. In my denominator here, when I multiply these two together, that's going to turn those into positives. And then we're going to add 1. So 1 is the same thing as 3 over 3 to get those common denominators once again. And so we're going to get 3 plus the square root of 3 all over 3. When we divide by fractions, we are going to multiply by the reciprocal. So I'm going to bring this down here. So negative square roots of 3 plus 3 divided by 3. We are now going to multiply by 3 over 3 plus square root of 3. And I'm just going to multiply this out. Now, what's going to happen here is these 3's are going to cancel each other out, which is great for us. And the rest of this then, there's nothing else we can do. So negative square root of 3 plus 3 divided by 3 plus the square root of 3. Now, if you did something like, say, 45 minus 30 or something like that, you're going to get the same answer, but you might have things a little bit different. Like, you might have 3 minus the square root of 3, but that's okay. And you might have the square root of 3 plus 3, and that's perfectly fine. I'll be able to tell those differences. And if you look at the answer key and you're not sure, just by all means let me know. Now, the other nice thing that happens with these is you can sometimes condense them to make them easier to do. So here, if I'm trying to find the exact value, when I look at this situation here, I don't know what the cosine of 300 degrees, well, I suppose I do know the cosine of 300 degrees, but cosine of 15 degrees, I don't know. And so when I start to recognize, well, here's cosine and cosine and sine, this is representing the sum and difference of cosine. And so since I am subtracting between the two, that means we're working with the sum. So we'd be taking the cosine of 300 plus 15. And that right there gives us the cosine of 315 degrees. Well, that we know on our unit circle. So if I find 315, the cosine of that is the square root of 2 over 2. And there's your exact value. You can also condense them. Okay, here's kind of a crazy one, working with a tangent and trying to condense it. First of all, from all of this, I just really got to figure out whether we're adding or subtracting. I can see that I'm working with a 5 pi over 18 and a pi over 36. And then here, since I'm subtracting in the numerator, that means that we need to do the difference. So we're going to be taking the tangent of 5 pi over 8, and this is where the order does matter. And then we'll subtract pi over 36. So if I simplify 18 here, we could rewrite that with 36. That would take this 5 and turn it into a 10. And so now the tangent, 10 pi minus 1 pi would be 9 pi over 36. And 9 goes into 36, that would be what, 1/4? So this is the same thing as the tangent of pi over 4 then. And we know that the tangent of pi over 4 is positive 1. Now, what if you look at a situation like this here? Okay, you can also use sum and difference identities to prove things as well as just simplify them down. So here I have the sine of pi over 2 times the cosine of alpha minus cosine of pi over 2 times sine of alpha. Now I can condense this if I wanted to. I see I'm taking the sine times the cosine, so we're working with the sine. And here's my first radian. This would technically be my second one. Since I'm doing subtraction, I need to subtract as well. So we would be taking the sine of pi over 2 minus alpha. Now, realize that using these, you can evaluate something like this as well, because you know the sine of pi over 2. The sine of pi over 2 is 1. So here we're taking 1 times the cosine of alpha minus the cosine of pi over 2. And the cosine of pi over 2 is 0 times the sine of alpha. Well, 0 times the sine of alpha is 0, and 1 times the cosine of alpha is cosine alpha. So right here, all of this can be simplified to the cosine of alpha. And I guess that's where I'm going to leave it. So, sum and difference identities, that's your new take on some of these trig identities. Let me know if you have any questions.